Hello and welcome to Microbiology Shorts, short videos on microbiology topics. I'm Rebecca Payne and today we're talking about competitive and non-competitive inhibition. So competitive inhibition is when a substrate cannot bind to the enzyme because there is a molecule called a competitive inhibitor that is bound instead to the active site of the enzyme. And so this prevents the substrate from binding to the enzyme. Competitive inhibitors sometimes are drugs and sometimes they are other molecules, such as a product of a metabolic reaction or a metabolic pathway, and they inhibit the enzymes in that pathway, or they inhibit a certain enzyme, and perhaps a product cannot be made, and this causes the cell to function well or not function well, depending. This is a way for a cell to shut down an enzyme temporarily, so that the enzyme doesn't have to be degraded, it doesn't have to be destroyed, it can just be shut off for a short period of time. It's kind of like a dimmer switch on a light switch. You can turn a light switch on, you can turn it off, but what if the cell doesn't want that enzyme to be completely on all the time? What if it wants to be 50% on? Well, if the cell then produces a certain amount of competitive inhibitors, those can block 50% of the enzymes that are creating the products and shut down that rate of reaction in total, so that the amount of product made is much less than what would have been made had the enzymes been functioning at their optimal rate. So in this picture here, we see the enzyme in purple, we see the competitive inhibitor molecule in blue, and we see the substrate above in red. You'll notice that the competitive inhibitor does not have a really tight fit to the active site like the substrate would. The substrate is perfectly fit to the active site, but the competitive inhibitor is just anything that's able to fit in the active site and prevent the substrate from binding. When this happens, there's no enzyme-substrate complex formed and no products released from this reaction. Let me show you a little bit of a video that explains this in real time so you can see how it works.
A competitive inhibitor is a substance that is structurally similar to the enzyme substrate, but which does not react to form products. For example, sulfanilamide is a competitive inhibitor for the enzyme whose normal substrate is para-aminobenzoic acid, PABA. Note the similarity in molecular structure of PABA and sulfanilamide. In competitive inhibition, competitive inhibitors compete with the substrate molecules for the binding site, slowing catalysis. However, if the concentration of substrate is much higher than the concentration of competitive inhibitor, the substrate will outcompete the inhibitor for the enzyme active site, and catalysis will continue.
Alright, so a couple of other things about this example here. This substrate, para-aminobenzoic acid, or PABA, is a precursor molecule to folic acid, and folic acid is a nutrient, a vitamin made by microbes. It can't be made by humans because humans don't have the enzymes to make folic acid, but microbes do. And so PABA, as it's started on its conversion pathway into folic acid, needs an enzyme to convert it in its initial steps. So this is why this drug, sulfanilamide, can be used to shut down a microbe, whereas it won't shut down a human cell. Sulfa drugs, which sulfa is a short term for sulfanilamide, sulfa drugs are common antimicrobial drugs used in the mid part of the 1900s, and in the Korean War, for example. If you watch the TV show MASH, you'll hear them talk about sulfa drugs. There weren't a whole variety like we have today of antimicrobial drugs available during that time. Of course, penicillin was discovered in the 1930s and not put into production in the 1940s. So in the 1950s, we're still in the kind of infancy of the antimicrobial age, as we call it. So sulfa drugs are important, and sulfa drugs acting as a competitive inhibitor, sitting in this active site of an enzyme. in the pathway for folic acid synthesis in microbes can shut down the microbe without shutting down the human cell. So that's important to kill a microbe, that you affect something that's only in the microbe and not in a human. Okay. So non-competitive inhibition is similar to competitive inhibition with one key difference. In non-competitive inhibition, you still have an enzyme, here in purple, you still have a substrate, here in red, and you still have an inhibitor, here it's shown in yellow. And the key difference between competitive and non-competitive inhibition is that in non-competitive inhibition, the non-competitive inhibitor is bound to the enzyme somewhere other than the active site. So you notice the active site here is empty, but the substrate still cannot bind to the enzyme in the active site. Why is that? Well, what the non-competitive inhibitor does when it's bound to the enzyme is it changes the shape of the enzyme, which kind of torques it into a twisted position. And when it twists, the active site also changes shape slightly. And when the active site changes shape, then the substrate can't fit any longer. So a non-competitive inhibitor is going to bind to the enzyme at the area other than the active site. It changes the shape of the active site. This change in shape prevents the substrate from binding. You're not going to get any enzyme-substrate complex formed and no products released from this non-competitive inhibition.
Non-competitive inhibitors bind to a location on the enzyme other than the active site. For example, the HIV medication nevirapine is a non-competitive inhibitor of HIV reverse transcriptase. Nevirapine does not bind to the reverse transcriptase active site. The binding of the inhibitor causes the enzyme to change shape, so the active site is no longer able to perform the reaction efficiently. Since the non-competitive inhibitor binds in a different binding site than the substrate, increasing the concentration of substrate has no effect on non-competitive inhibition.
Well, this has been another microbiology short. I hope you've enjoyed it. Have a great day and come back again soon.